Hello and welcome to my intro course into formal logic. Today I will cover the fundamentals of propositional logic. I will cover the basic stuff, so everything you need to know about propositional logic. However, I will not fully cover the mathematics behind it. So if you are truly interested, I would recommend you watching my other video also about propositional logic. In propositional logic, the most important thing are the statements. A statement can either be true or false. So as we see, this statement is false because 3 plus 4 is 7. So we here have a statement that's, well, we don't know yet if it's true or false, but it can only be true or it can be false. This statement, well, is simply true. If you stand in the rain, you will get wet. So you see, statements can be true or they can be false. Now you know what a statement is. I'll show you how they can be connected to each other. So let's look at this sentence. My name is Raoul and I'm a student. So we have the statement over here, my name is Raoul, that can either be true or false. And I'm a student. So the part I'm a student is also a statement. So we have two statements over here connected by an and. We have another sentence over here, and that's if it rains, then the flowers bloom. So it rains, that's a statement, and the flowers bloom, that's a statement. So we have if it rains, then the flowers bloom. So the if then also means something. And the last one, I'm drinking water or I'm reading a book. So we have two statements over here. I'm drinking water and I'm reading a book. Those can either be true or they can be false. And the or connective over here does mean something. So statements can be combined in different ways. Because we're a bit lazy, we replace my name is Raoul with a. And we replace the statement I'm a student with b. So instead of my name is Raoul and I'm a student, we get a and b. A and b are also statements. They can also be either true or false. But it makes it a hell of a lot easier to write them down. Also over here we replaced it rains with a and we replaced the flower bloom with b. Over here in this example exactly the same. We replaced I'm drinking water with a and I'm reading a book with b. So statements can be replaced with propositions. We call A and B propositions. We replaced our statements with the letters A and B. So we have A and B. These were our previous statements, still are statements, but now shortened in A and B. So we still have the and over here, and I find that still a bit too much work. So we're going to replace the and with something else. So we have a, and we're going to replace the and with the logical and. We call this the logical and. So we can see that and equals the logical and. And with or it's quite the same. So you have a or b, and we replace them with the logical or. So a or b. So we have the or equal this guy. Then we come to if a, then B. We replace this with an arrow. So A, arrow, B. So this arrow, you can just read it as if A, then B. The arrow they also call implication. So we have if dot dot dot, then dot 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 equals the arrow. Well, then we get some new guys, because we also have the operator not A. You can see it as an inverse. If A is true, not A is false. If A is false, not A is true. We just write this as this. This is the same as not A. So not equals this guy. And we then have if and only if. So A is only true if and only if B. We can shorten this by a double arrow, or an arrow with two heads or something. And this is called if and only if. In Dutch we say des da. Dan en slechts dan. To recall, A was a statement. And it could be true or false. It can be true or false. Well, we're really lazy, so we're going to replace true with a 1 and false with a 0. So what can we do with this? So, for instance, we have the statement, my name is Raoul. So we have my name is Raoul. We call it A. Well, not A means my name is not Raoul. So now this statement can either be true or it can either be false. So my name can be Raoul. So if my name is Raoul, it's true. And if my name is Tom, then this statement is false. What not A says is my name is not Raoul, or not my name is Raoul. So it's quite the inverse. So if my name was Raoul, so the statement was true, then the statement now is false. And if my name was Tom, what would make this sentence false? It would make my name is not Raoul true, because then my name would be Tom. So I would be saying a true thing. So we made a truth table now. So when this statement is true, then the negated version of the statement is false. And if it's false, then the negated statement is true. Okay, so I hope you get it a bit. So we're going to the next example. And that's the and. So we get A and B. So A is still my name is Raoul. And now we're going to replace, well, B is going to be I like fish. I like fish is B. So we got two statements now, and they can be true or false. Note that there are now 4 different combinations because we can make, well, let's make a nice table again. So we have A and B. They can be false together, so they can be both be 0. Well, A can be false and B can be true. A can be true and B can be false. And you got the last combination, A can be true and B can be true. Now we made all the combinations. So, what does A and B mean? So, A and B means that if A is true and if B is true, then this whole statement is true. Otherwise, it's false. So what we just said is if A is true and if B is true, then this statement is true. Otherwise, it's false. So, my name is Raoul and I like fish, then it's true. If my name isn't Raoul and I don't like fish, then it's false. So that's the top one. If my name isn't Raoul, but I do like fish, the statement is still false. And the other way around, if my name is Raoul, but I don't like fish, then the statement is still false. Well, that's a nice definition, isn't it? So, you can make this truth table with an AND. On to the next example. We got the if then. So if A, then B. So we got if A, then B. Well, we're going to replace A now with it rains. And B with I get wet. So we make another truth table. So we have A and B. So we can have those 4 combinations again. I'll just always write it like this. This is 1, 1. Okay, and then we have A, B. A implicates B. Well, if it doesn't rain, then I don't get wet. So it doesn't rain, so it rains is false. And I get wet, well, I'm dry, so B is also false. So if it's dry, then I'm dry. Well, that's a good one. So this 0, this means that it doesn't rain, but I'm wet. This is a confusing one. It's a bit confusing because I can get wet in different ways. That's how they state it. Because, well, I can take a shower or something. So because it doesn't rain doesn't mean I can't get wet. So this is still true. So we get a 1 over here. So, and now we get something else. It rains, but I'm not getting wet over here because B is false. Well, the if-then relationship states that if A is true and the B is false, then the whole statement is false because A says something about B. If it rains, I always need to get wet, according to this statement. It doesn't have to be true, but this is the statement what I get when I use an if-then relationship. So that means that this has to be a 0. This is false. This statement is false. Okay, well, the last one. It rains, so I get wet. This is an easy one. This is a 1. So now we got the and, the if-then. We're still missing the or. So we're just going to scratch this one out. And we're going back to my name is Raoul. And I like fish. So the or is quite, well, if you just follow the rules, it's easy. If you just know the right truth table, then it's no problem. But in the normal language, we can have other definitions of ors, because it can be an exclusive or also. But we're now talking about the normal or. I'll give an example. So we have A or B. So my name is Raoul, or I like fish. You can see there's an exclusive or. Then my name can only be a Raoul, or I can only like fish. And we call that the exclusive or. And that's an other symbol. It's a symbol with a cross, a circle with a cross in it. But now we're going to the other or. So this means that if my name is Raoul, or if I like fish, then it's true. So only when they're both false, so my name isn't Raoul and I don't like fish, then only the or is false. So here they're both false, so then the or is false. But in either other way, my name isn't Raoul, but I still like fish, then it's still true. Same here. Now my name is Raoul, but I don't like fish, so it's still true. And the last one, my name is Raoul, or I like fish, are both true. So this one is also true. So this is the truth table of or. Well, I can show you the exclusive or. So we get 0, 1, 0, 1, 0, 0, 1, 1. And then we have a exclusive or XOR B. Well, I'll just give you an example. It's only true if one of these is true. Not when both are true and not when both are false. So it's not a hard one. I think this one is a bit more intuitive than this one, but you'll get used to both. This one is used a bit more. Well, the XOR is used a lot in cryptography, but not about that. So we still have the if and only if. So my name is Raoul if and only if I like fish. So that one is only true when both are false or both are true. I'll show you the truth table over here. So, if my name isn't Raoul, then I don't like fish either. So, my name is Raoul, isn't Raoul over here because it's false, and I don't seem to like fish over here. So, oh, sorry. Then this needs to be this needs to be true. So, in this example, it's false because I like fish over here, but my name isn't Raoul, so it's a false. And my name is Raoul over here, but I still like fish. But I don't like fish, so it's false because if and only if my name is Raoul, then I like fish. So my name is Raoul if and only if I like fish. Well, now we got the basics. We can move on to the bigger formulas. So we got a big formula over here, and we want to know the truth table of this one. So we have if A, then not B, and C or A. So how in the hell are we going to evaluate this and how are we going to start? So notice over here we got all the possible combinations of truth of the truths of A, B and C. So as you see over here, they're both false, then only C is true, then only B is true, then B and C are true, A is still false, and then we get the same pattern over here only with A true. So these are all the possible combinations. So because we see parentheses over here, that means that we need to evaluate this part of the logical proposition as first, and we need to evaluate this part first, and then we're going to evaluate this part. So to make it easier, I gave the examples, the previous two truth tables of a normal A and B without any big extra signs with it, and a negated B over here, inverse B. So we're first going to evaluate this part of the function. So we got A, arrow, not B. Okay. Well, as we see now, that A arrow B, always when A is false, this part in the truth table is always true. The first part of our statement is always true because of A being false. So that means that it doesn't matter what B says. Okay, now comes the tricky part. B turns around because it's inversed. So this 0 of B is now a 1, and this 0 of B is now a 1, and this 1 of B is now a 0, and this 1 of B is also a 0. So as we see in the previous truth table, when B is 0 and A is true, then the truth table of A implicates B is false. So now we got to 1 implicates 1 over here because B being negated. So we get a 1 over here, also 1 over here. But now this is a 0 and this is also a 0. So we get a 0 over here and a 0 over here. Well, the second part, this part, C or A. This was also quite simple rule. When one of these two is true, or when both are true, then the part in the truth table is also true. Only when they're both false, then they're not true. So they're both false over here, so that's a 0. C is true over here, so that's a 1. Both false over here, so that's a 0. And C is true over here, so that's a 1. But now you see that A is true everywhere, so we can just simply put 4 1s over here. Well, now we're going to evaluate this part. So do you still remember the AND rule? So that was only true when in both cases A and B were true. So that means that this one is false, this one is true, this one is false, this one is true, this one is true, this one is true, this one is false, and this one is false. So we get 0, 1, 0, 1, 1. Let me count. 1 more 1. 1, 2, 3, 4. 1 more 1, and then 2 zeros. No, that's 1 too many. But it's okay. Things were getting pretty big over there. We had 3 statements on already 8 different rows. If we would add another statement, we would get 32 different statements. If we would add another different statement, we would get 64 different possibilities. So we got a formula over here, 2 to the power n, and n being the different statements. So if you have 3 different statements, then it's 2 to the power 3, that means 8. So 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64. So it's get bigger and bigger. Well, some other definitions. We got the formula A implicates B, implicates A, implicates A, and then we're going to set some parentheses. We got a 1 here, and we got 1 over here. Well, let's evaluate this statement first, and then you'll see what's so special about this statement. So we got A and B, so we only have 2 statements, so we can get 4 different results. So we'll first evaluate this part, and then we'll evaluate this part, and then we got the entire part over here. So we got A arrow B, so that's 1, 1, 0, 1. Now we got that arrow A, yeah, there's an A, sorry. So that's 1, 0, that's 0, and that's 1, 0, 0, and that's 0, 1, so that's a 1, and it's 1, 1, so that's a 1. Well, now we'll compare this together, so we'll get 0, 0, 0, 0, 1, 1, 1, 1, so that's always 1. Check it yourself. Well, this is special because every row has a 1. This means that this formula is a tautology, or another, so this means a tautology. Or in different words, this formula is always true. You can write it down as this. Well, then we have another one, another sign, and this is this sign, and this means this part, or this this statement has the same truth table as this statement. So when you have the same truth tables, I'll show you one, and that's not A, arrow B, oh sorry, there's some parentheses, and is equal to A and not B. So how we're going to see this? Well, we'll just make a truth table. So we got A and B over here, 0, 1, 0, 1, 0, 0, 1, 1. So A arrow B is always 1, 1, 0, 1. But because it's inverted, you get 0, 0, 1, 0. 0, 1, 0. Because of this one. Well, A and not B. So B is inverted, so you get 1 over here, 0 over here, 1 over here, and a 0 over here. So because it's an AND, the only true thing is when they're both true. So A is 0 over here, B is 1 over here. So that doesn't matter, that's always 0. 0 over here and 0 over here. Hey, they're 1 over here, and B is 1 over here. And A is 1 over here, and B is 0 over here. So we get this truth table, 0, 0, 1, 0. Hey, they're the same. So we can put these 3 stripes over here. Because some of the statements have the same truth table, we can make some handy rules. So these rules, that not A or B equals or has the same truth table as not A and not B, and the rule not A and B has the same truth table as not A or not B, are called the laws of De Morgan. And they're quite handy sometimes if you need to rewrite a formula.